Yes, perfect. If you all
Okay.
agree,
Then I will do that now. This I can do simply by sharing one window. If I find the right one, and this is the right one. Now you can still hear me?
yes, perfect.
Okay, so yeah. So to build the FORTHMOBILE, it should look something like this with an ESP32 and some other items on it. This is the motor controller. These I have mounted 3 of these laser rangefinders on it, and 1 compass. And I have a place for mounting a GPS system on it. That's the input to the system. Then there's the ESP32. Then I've made a board for it, so I've broken out things that I need in order to connect it. Then I have here's a link to how to get started with this, all the software and tools that you need. And that's here's a simple program, how to blink the lights on it. So I have a constant for on and off. I have 3 pins that I use for these 3 laser distance meters. Then I can shut each and every one of them on and off with these 3 words, and that will make these LEDs here blink and activate and deactivate these 3 sensors. Now, in order to access this from Wi-Fi, you need to add a file called autoexec.fs to the spiffs directory. I upload those using the ESP32 data uploader, and I set an SSID and a password, and then I start a telnet server, and from then on I can access it over telnet. Then I need to access the motor, the 298 controller. So I define constants for all the pins that are on that controller. Then I have some constants for directions. And then I set them up using these pin modes that everyone should recognize from the Arduino IDE. And then I set a speed on each of the motors, one for the left side, one for the right side. Then I have one that puts them both together, so I can go in a straight line forward or backwards. Then I have the most important of all, that's the stop. That's when it's doing things it shouldn't be doing. And then I have what I've called the gearbox. That's just initializing these pins that are also used for servo motors, so that they will go either forwards or backwards. And then I have one that sets these gears. It's called drive. So it sets the left and right speeds, and then it sets the direction forward or backwards. And then it just, this is how it works. It just gets that value of the stack, sends it to the left, and hold on, it sends the direction to the left and right, and then it sends the speed to both motors. And it can also turn on a dime. That's the motor, and then it's the auto drive. So all of these get uploaded. I upload it using this upload extension to the Arduino IDE. So here it's about obstacles. Does it see an obstacle on the front, on the right, on the left? I also take care of these values because even if you tell it to go in a straight line, it won't do that. It will always go to one side or the other because these motors, they don't turn at the same speed when you give them the same PWM value. So you need to somehow make sure that it stays on course. Then I read all the sensors, and then I correct the course. So I read the course from the compass, and then I compare it with the course that we want, the desired course. And then I just subtract it, and then I do the correction here by adding to the left or right PWM values, and that should hopefully get it back on the right course. And then when it sees an obstacle, then it will back off and stop. When it sees an obstacle to the left and to the right and to the front, then it will not do anything else. It will exit the loop. You'll see that later. If it sees an obstacle to the left, it will try to turn away from it, and the same on the right. And here is the main loop. So it will read the sensors. It will initialize both speeds, left and right, to 200. It goes from 0 to 255, and then it will give the command to start driving. And then here is the loop. It will plot radar values. That's for an application that I've developed for a mobile phone that I'm not really finished with, but it will plot like a radar screen on the mobile phone. I thought that looked kind of cool. Then it will read the sensors, correct the course, decide the action that I showed you up here, avoid obstacles, and if it's boxed in, it will stop. And that's all I had for the code. I think I can show, perhaps I can show it actually driving. I might be able to do that.
Well, you can show the video without sound if it's driving.
I should be able to show it without the sound. Yes. Hold on, if I can.
Ronnie has probably some questions. He's interested in robotics. He did this.
Yes, sir. Sir. So maybe it's not easy question or not. When I try to coding with Arduino IDE, we use pin mode, we use blah blah. But here I see Forth code sequence is totally different with Arduino IDE. Am I right or wrong, sir?
Yes, what you have to do in the IDE is that you have to load the program that Brad just presented, yes, and that is an INO file. And then to that INO file, you have to add the libraries that you will be using. Yes, and when you've done that, you need to add some macros to the INO file. This is not overly complicated. You will get a feel for it when you've looked at it for a while.
And
then
In the end of the demonstration, I will show installation very briefly, very rapid of the ESP32 Forth.
Yes, well, from that point on, you can start adding the codes that I just showed you. And you can upload those, you can change them if you need to. If you made a mistake and you uploaded a code with an error in it, you don't have to reflash or anything. You just upload the correct code again and it will overwrite the old one. Did that make sense? Sorry. Hello?
Yes, sir.
Yes.
Okay, now I will try to show a video that should show how this works. Let me see if I can share the screen again. Find the correct window. Can you see a picture of a robot and a screen now? A screenshot?
Yes, yes.
Okay, well, here you should see it. How it's done. First, you connect over Telnet. And if you get first you turn on the FORTHMOBILE. That's very important. If it's not turned on, it won't work. Now it's on. So now you should be able to connect to it. And then you can type in the commands directly. So you control it just like you would control a terminal. Like you type in things at a terminal. That's exactly how it works. And now you give it instructions to go forward. And to stop. And those buttons that I'm pressing there, it would be the same if I just typed the commands in at the prompt there. I just added those buttons to make it easier. So that's one video that shows how it works. I have another one here that manipulates the servos. So I'm just loading that. And then I'm uploading that to, you upload, this is what you upload. What you see there, it was marked, that's all you need to do in order to reprogram the FORTHMOBILE. So you don't flash anything, you do this while it's driving. And then you can take that code that you just uploaded, and you can execute it to make it look left and right. That is something that was coded now in the last seconds. So that's what I had.
Delightful. That's very impressive and very beautiful code, actually. Yes.
Very cool project, yes.
Great, sir.
So did that make sense at all?
Yes, sir. Yes, sir.
Yes, it did.
Very nice.
Excellent, excellent.
Could I ask you a question, Atle?
Yeah, sure.
You gave me the itch to build my own with all this, but it's hard to find parts here where I live. I have to wait 2 to 3 months to get anything from China, or pay 3 or 4 times the price in Montreal.
Same problem here.
Could I start from a toy sale after Christmas and get one of those 1 foot long toys and work with this? How do you feel about the idea?
Well, what I did, I bought all these different parts separately. But what you can do is you get those kits. What I did here. This is a metal plate. That's not necessary at all. You can get this and this as a kit, as a plastic kit. Then you buy that motor controller, and then you buy the ESP32, and then you should probably I have a proto board here, but I've also made this board, which is a lot more reliable. So I plug the ESP32 in here. I plug in the sensors, and then I'll just 3D print a plate to put on top of this chassis, and then I'll mount this on top of that plate. That's how I do it. So you could start with any kind of kit that you can buy in a store. It doesn't have to be identical to this. It must have the motor controller, unless you want to program that from scratch again. And it must have an ESP32 and some way to hook it all up together. But
See, I have something to get started. So I don't know if you'll see this, but this is a CNC controller that a friend of mine built. Okay, and it uses the ESP32, and it's got isolated outputs, and it's got the solid state relays that you could put in there. And so I could probably, and access to pins on the side. So I could probably use that as my motherboard.
absolutely. I mean, you're an electronics guy, right?
Well, mostly I'm a hardware guy.
Yeah, so you'd have no problem figuring that out.
Christian, have you visited the Robot Shop Canada? Robotshop.com, they're based in Canada.
A few times. I think my friend for his CNC got some parts from them.
They seem to have everything you need.
Oh, so maybe I should take a look at that, because I'm just not doing anything with hardware, because anything I order takes too long to come here. And let's say I'm cheap. I don't like to pay 3 times, 4 times the price.
I get all my stuff from AliExpress, and I'm so used to waiting. I have a second board that I've started to. It has a lot more I/O. It has some registers on it so that I can get more I/O out of the ESP32. But this is as far as I got, because now I'm waiting for sockets from AliExpress. That's patience is a virtue when doing this. Or you have to have a lot of money.